G'day. This is GMT muzzle brake version 4, part 4. I've zoomed everything in to try and make the whiteboard as clear as possible, and I'm going to explain how I'm going to go about rotating this guy around and working out where I'm going to be placing my holes based on what it requires 5 turns. The dividing I have has a simple 40-to-1 gear ratio like many of them, so it was easy to determine that I've got to rotate it 8 turns to get my desired location. So 8 turns is hole 1, the next 8 holes is hole 2, the next 8 turns is hole 3, the next 8 turns is hole 4, and then the next 8 turns give me my last hole. Therefore, if I'm looking at which angle I'm going to for location 1 and 3, I've got to utilize going from top dead center. My first turn is to degree 72, which equals 8 turns. So by turning the crank 8 times, I advance around to 72 degrees. To get to 144, I crank it again another 8 turns, and that'll stop me at 144 degrees, which would mean that this one originally had started over there. I keep that process going until I get back to top dead center, which is another 8 turns. So that means I have rotated a full 360 degrees. To get to the next ones, I've got to rotate from top dead center around half of my 72 degrees, which was 36. But then I need to maintain my rotation of the same amount to get the holes in the same spot. So for location 2 and 4, starting at top dead center again, because I'm using that as my reference because that's where my tool will be coming in all the time, I've got to go 36 degrees, which would mean that this is actually turning around, so part of the material would end up here. Drill, mill drill, whichever operation I'm trying to do, and then I need to rotate 72 degrees from that location. So as I'm turning this way, I've got to go to 108 degrees would be the full index. So I've got to go 4 turns, then another 8 to get my location. Then advancing from this location, continuing around to my final hole, which is at 324 degrees, I need to make another series of 8 turns. But to get the tool back to top dead center for making location 3 now, because I'm going to be advancing to that, I've got to get back to top dead center as my true reference, which is only 4 turns. Then I'm at location 3, repeat. When I finalize that, I'll need to move to location 4 and repeat the second process. This is all referred to as simple indexing, and with the setup that this has, that's very easily done. The reason I covered this up is because pretend that we were having a weird degree that we were trying to utilize. Then I would need to utilize angular indexing and utilize my indexing plate that's on my dividing head. And the holes I have on my dividing head, I have 6 of them, and it's the only plate I got. So I've got a 17 hole, a 19 hole, a 27 hole, a 29 hole, a 33 hole, and a 39 hole. Utilizing the machinery handbook, there are tables that we can utilize to do that. So with this table here, I'm able to go and get the minutes that each one of these holes represents. So one hole in the 17 hole in the circle represents 31.764 minutes, and then we proceed to change ultimately. The good thing I have is a 27 hole, which gives me 20 minutes, and I'll explain why that is a good thing to have. If we go back to looking at our gear ratio, but thinking in terms of degrees, one full rotation is 360 degrees. Divide by 40 gives us each turn is 9 degrees. So if I had a 9 hole down here, each turn of that is 1 hole. Each hole is 1 degree till I came back. And then I would keep doing 40 turns to get my whatever's. The next hole plate would be up here, 18 holes in the plate. So each hole is half a degree. So I need to move my indexing head 2 holes on the 18 hole one to get 1 degree. Now I have my 27 degree one, so to get 1 degree I got to move that to 3 holes in the plate. So using these relatively simple divisions and utilizing angular tables, which are also in the machinist's handbook, we can break up our angles. And if I needed to do the 45 degree 48 minute location, I need to split it up, because 9 degrees into 45 is 5 turns. It's not an easy division, so I need to split the 48 into something I can utilize. So 45 plus 3 degrees gives me my 48. I know that 3 degrees, for each degree there's 3 holes, so I got to go 3 times 3 is 9 holes. So I got to move 9 holes in my 27-inch plate, 27 hole plate. I still have my 40 seconds to deal with, but I know that each hole is 20 seconds. So I need to advance it another 2 holes to get my full 48 degrees 40 minutes. Therefore, for the total angular rotation, I have to do 5 turns, 5 full turns, and then I need to advance 11 holes in my 27 hole plate. So that would give me the final thing. So my preference is to utilize simple rotations without having to think too much about rotating, placing a hole, etc. But this is how we're going to do it.